In this video, we're going to continue to talk about degrees and radians. And specifically, we want to talk about coterminal angles. Coterminal angles, it happens when different measurement of angles have the same initial side and the terminal side. So let's take a look at this two measurement of angle alpha and angle beta. Here's the initial side and here's a terminal side. When you measure an angle alpha, you're going counterclockwise. So it's going to be a positive measurement. What is it? It looks like this is going to be 180 plus 45, which is 225 degree. What about angle beta? Angle beta, you're going clockwise, so it's going to be a negative angle. So it's going to be negative 90 and negative 45, which is going to be negative 135. Now, they have a different measurement. Alpha is 225 degrees. Beta is negative 135 degree. However, they both have the same initial side and terminal side. These two are the examples of coterminal angles. Let's take a look at this example. Look at alpha. In this case, alpha looks like positive 60 degree. Now what about beta? Beta, you go up to 60, but you're taking one more revolution. So it's going to be 60 plus 360, which is going to be 420. So basically, alpha and beta have different measurement, but again, they have the same initial side and the same terminal side. So 60 and 420 are another examples of coterminal angles. So if alpha is the degree measure of an angle, then all angles measuring alpha plus 360 times n, where n is an integer, are coterminal with alpha. So for example, if alpha is, let's say 30 degree. To get another coterminal angle, you could keep adding 360. So 330 plus 360 is going to be 390. 30 and 390 are coterminal angle. You could add 360 again. And also you could subtract 360. So 30 minus 360 is going to be negative 330. So negative 330 is another coterminal angle with 30. And you could keep subtracting 330. So you have infinite amount of coterminal angle with alpha. Now what about if alpha is radian? Let's say alpha is pi over 6, which is the same thing as 30 degree, if you change it to a degree. Now, in order to get other coterminal angles with alpha in radian, now in this time, instead of adding 360 or subtracting 360, you could add 2 pi or subtract 2 pi. So pi over 6 plus 2 pi is going to be pi over 6 plus 12 pi over 6, because that's the same thing as 2 pi. You get 13 pi over 6. Or you could subtract pi over 6 minus 2 pi, which is going to be pi over 6 minus 12 pi over 6. And that's the same thing as negative 11 pi over 6. So again, you have infinite number of coterminal angles with alpha, whether the angle is in degree or radians. So let's take a look at this example. It says identify all angles that are coterminal with a given angle, then find and draw one positive, and one negative angle coterminal with the given angle. So given angle is 45. What are all coterminal angles to 45? Well, it's going to be 45 degree plus 360 times n degree, where n is an integer. So if you multiply n, where n is an integer, that gives you a coterminal angle with 45. Now, what is a one positive coterminal angle? Well, when n equals 1, it's going to be 45 plus 360, which is going to be 405 degree. And how do you draw 405 degree? Well, what you need to do is, since 405 is positive, again, you start with the initial side, which is on positive x-axis in standard position. So you need to make one revolution or rotation to get 360. And you need 45 more degrees to get to the terminal side. So this is an example of 405 degree. Now, what about when n is negative 1? When n is negative 1, it's going to be 45 minus 360 degree, which is going to be negative 315 degree. Now, how do you draw negative 315 degree? Well, in this case, again, we start with the initial side on positive x-axis. Now we have to go clockwise. So this is going to be negative 90, negative 180, negative 270, and then we need 45 more to get to negative 315. So this is negative 315 degree. And you could notice that this is going to be 45. So again, negative 315 degree and 405 degree are coterminal angles because they have a different measurement, but they have the same initial and terminal side. Now, what if the angle is negative pi over 3? What are all the coterminal angles? It's going to be negative pi over 3 plus 2n pi, where n is an integer. So this will give you all the coterminal angles with negative pi over 3. Now we need to draw one positive and one negative angle coterminal with negative pi over 3. So let's say n equals positive 1. Then you get negative pi over 3 plus 2 pi, which is going to be negative pi over 3 plus 6 pi over 3, which is going to be 5 pi over 3. Now remember, 5 pi over 3 is the same thing as, that's 180, 180 divided by 360, 300 degree. Because when I draw an angle, I like to work with degree rather than radian. But it is up to you. So how are you going to draw 300 degree, which is the same thing as 5 pi over 3? It's going to be, since it's positive angle, you have to go counterclockwise. It's going to be 90, 180, 270, and then we need 30 more degrees. So approximately over here. So this is 5 pi over 3. Now, what about a negative angle? Well, what we could do is let n equals negative 1. When n equals negative 1, you get negative pi over 3 minus 2 pi, which is the same thing as negative pi over 3 minus 6 pi over 3. And that's the same thing as negative 7 pi over 3. Now, what is negative 7 pi over 3 in degree? That's going to be 180 divided by 3, which is 60. 60 times negative 7, negative 420 degree. So negative 420 degree is same thing as negative 7 pi over 3. Now let's draw an angle. Since we're going negative, you have to go clockwise from the initial side. So this is negative 90, negative 180, negative 270, negative 360, and then we need 60 more degrees negative direction to get negative 420. So this is going to be, that's negative 7 pi over 3. Now notice, 5 pi over 3 and negative 7 pi over 3 are coterminal angles. That's why they have the same initial side and same terminal side, but different measurement. Now we're going to talk about how do you find the arc length. Well, earlier we talked about the central angle theta is S, where S is the length of intercepted arc over radius. So it's going to be the intercepted arc, which is the arc length, is going to be, when you multiply both sides by r, you're going to get r theta. So that's how you find the arc length. But be careful, theta is measured in what? Radians, not in degree. So let's take a look at some examples. So they want us to find the length of the intercepted arc in each circle with the given central angle, measure, and the radius, and round to the nearest tenth. So what is the central angle they give us? Well, central angle is pi over 4. It's in radian, so that's good. And the radius is 5 centimeters. So what is going to be the arc length? It's going to be r times theta, which is 5 times pi over 4, and that is 5 pi over 4. Now you need a calculator to evaluate this. Now remember, pi is approximately 3.14, but don't use 3.14. Use the calculator, enter pi, and you'll get a more accurate answer. And this is approximately, when you round it to the nearest tenth, it's going to be about 3.9 centimeters. Again, the reason why we need radian is so that we could measure the distance. Otherwise, we will not have a centimeter. And let's take a look at this example. The central angle is 60 degrees. But we have a problem with that because they said that the angle has to be in radian. So we have to change 60 degrees to a radian, which is pi over 3. Now what about radius? Radius is going to be 2 inches. So the intercepted arc is 2 times pi over 3, which is 2 pi over 3. And using your calculator, this is approximately 2.1 inches. Now if you know the measure of central angle theta and the radius of a circle, you could also find the area of a sector of a circle, which is going to be 1 over 2 times r squared times theta. Again, where theta is measured in radians, not in degrees. So in order to find the area of a sector of the circle, basically we're looking for the area of this portion right here. And here is the formula to find the area of a sector. So what is the central angle? Central angle is going to be 7 pi over 8, and that's in radian. So it's good. What about the radius? Radius is 3 centimeters. So the area is going to be 1 over 2 times radius squared times 7 pi over 8, which is going to be 9 over 2 times 7 pi over 8. And that's going to be 63 pi over 16. And if you use your calculator, you'll get approximately 12.4 centimeters square. Remember, this is area, and we have to square the radius, so we get 12.4 centimeter square.